significant figures, scientific notation, and rounding. Okay, I didn't know about this until someone pointed it out to me, but this is just a guide for further maths. Your chemistry teacher or perhaps some other subjects may give you different rules. It's not because they don't know their subject, it's because the VCAA guidelines are different for maths and for maths that's used in chemistry. This video is the mathematically correct one, but if your chemistry teacher tells you something that contradicts with what I'm saying, it's because that's what they've been told to say for chemistry, but this is actually what they're supposed to be doing in chemistry, but aren't. Okay, this is Mount Everest, and when they measured it back in the day, they found it to be exactly 29,000 feet, which they used to write like this, 29,000, and then do a little dash like that. So if you look at this, the problem is you don't know whether these zeros are being measured or not. So they're like going, it's 29,000 feet. You're going, is it 29,000 to the nearest 1,000 feet? Or is it 29,000 to the nearest 1? And because they both give you the same answer, right? But you can see clearly there are different maths. So what you look at here is this part here is telling you the significant figures, right? Given this, but then the other part is telling you, this part is telling you the magnitude, or the size of your ruler, basically. Size is another way to talk about magnitude. So the point is, which one was it? Now, if you do a thing called scientific notation, you'd actually can write it like this. So it's 2.9 times 10 to the 4, and that would equal 29,000. All right, so let's just explain that a little bit in detail. So this 4 up here tells you how many decimal places to move it. So if you've got your number 2.9, we're going to move it 4 times bigger. So 1, 2, 3, 4, there's our decimal place. And then you've got to put some zeros in here because that's what they're covering. And you can see that 2.9 times 10 to the 4 does equal 29,000. But you could have written it also as 2.9000 times 10 to the 4. And that still equals 29,000. And you still have to move the decimal place 4 times. But you can see that 1 is much more accurate. This one's only got 2 significant figures, whereas this one's got 5 significant figures. So I might call them sig figs because that's what people call them, because they can't be bothered saying significant figures. And so you can actually see the accuracy in scientific notation. So these things are in scientific notation. So it's scientific notation. And that's why people actually use scientific notation. It tells you the accuracy. So the significant figures tells you the accuracy, and then the other part, the magnitude, tells you how big that number is, or indeed how small. Now, this is an examples of why scientific notation is so good, because instead of having to write a long string of zeros, and I'm not even sure I put the right number of zeros there, to be honest, you can just write it like this, you see, and you say times 10 to the negative 31. Notice it says negative 31 because this number is much smaller than 0. So when you're writing really, really small numbers, or indeed like with the mass of the sun, a really, really big number, again, you've got a string of zeros, you just say times 10 to the 30, and that makes it much easier. You don't have to count zeros or wonder if you've typed the right number of zeros or anything like that. Now, over here, I'm just showing you on the calculator that you can see, like, you type it in like this. Now, when you do it on your calculator, you probably don't do it that way, but the starry symbol means times. And it says times 10 hat negative 31, and that just means the same as this. But your calculator will convert it into this weird format and do this. So you can see all 3 things are exactly the same, and we'll just use a slightly different color for this one. So here we said times 10 to the power 31, so that's times 10 hat 30, not 31. And then here you can see we've got E, and it's got a little plus symbol, 30. So just get used to that format and don't freak out or ignore these E situations, because they do come up and people do make mistakes and then get things wrong on exams or SACs. Okay, the best way to do this is by doing some examples. And so if you want to pause the video and try for yourself, and then I'll go through them in a second. admit it, you just waited for me to tell you the answers. All right, how many significant figures does this first number have? Well, this first 0 doesn't count because it's not between any other digits, but this 0 counts because it's between some digits. So we would say that this has 5 significant figures. Now, if we're going to go to 3 decimal places, we go 830, we're going to cut off there. The 0 looks at the 5, we don't need any other digits, the 0 looks at the 5, and that tells us that 0 to 4 stay on the floor, 5 to 9 climb the vine, if your primary school teacher told you that. So 0.831, because we have to climb the vine. 3 significant figures. Well, the first 0 is not significant, and so 831 is significant. Now, when you're doing scientific notation, you start with the first significant digit, so that's going to be an 8. So you never have a 0, and then you do 0.31. And if you look at this, we had to move the decimal place 1 place. So that's why when we write this, we write times 10 to the minus 1. So we minus because we want the number to be less than 1. Our original number is quite small. Okay, so 1 because of 1 move. Now, let's try the next number. If we look at the next number, this 0 doesn't count, so we've only got 4 significant figures. If we go to 3 decimal places, you go 1, 2, 3, you can chop off here. The 8 looks at the 9, that means we're going to have to climb the vine, so it's 0.299. And 3 significant figures is going to be exactly the same, 299. And again, so our first digit is 2, and we put a 0.99. And we say times 10 to the minus 1 because we did that 1 move. All right, let's try the next number. Looks very similar. Again, we've got 4 significant figures, so that's pretty easy to see. But this time, 3 decimal places, that's cutting off here, isn't it? So we've only got 3 decimal places, so we just write the number again, 2.989. But it's going to be different if we do 3 significant figures because the 298, we cut off here. The 8 looks at the 9, climb the vine, so it's going to be 2.99. So we start with our first digit, 2, and then we put the rest of it, 0.99, times 10, and to the 0 because we don't want to move it. So 0 means 0 moves. All right, next one. Again, these zeros don't count, but this one does, because it's between digits. So we've only got 4 significant figures here. And so if we round this off to 3 decimal places, we would count 1, 2, 3, chop it there, 5 looks at the 0, 7 and 2 don't matter. So we're going to stay on the floor, 0.005. All right, now we're going to start getting some big differences here because if we look at significant figures, then we start at the 5 and we go 507, 7 looks at the 2, and so we'd actually write 0.00, none of those are significant, then 507, staying on the floor again because of the 2. And if we write this in scientific notation, you would write 5, because that's our first significant digit, 0.07 times 10. Now, we know it's going to be negative because it's smaller, but it's 1, 2, 3 moves, isn't it? So that means it's going to be times 10 to the minus 3. Next one. If we look at this one, we've got some zeros, but they're between digits, so everything counts. So that means we've got 6 significant figures. All right, 3 decimal places. So we go 1, 2, 3, that chops off there. 3 looks at the 4, nothing's happening there, so it's going to be 12.003. All right, 3 significant figures though. Be 1, 2, 0, we chop off there. 0 looks at the 0, nothing happening there. So we're going to write 12.0. And so if we put that in scientific notation, we have to say 1.20 times 10. Now let's have a look at our moves. We want the actual decimal point to go 1 that way. So it's going to be a positive and 1 because of 1 move. All right, let's try this one more time. So if you look at this, we've got some zeros at the end here. Now they aren't significant because they're not between digits. So this has only got 4 significant figures. So 3 decimal places, well, we don't actually have any decimal places given. So 94240.000. So you can see we're kind of making things up there, which doesn't feel very good, does it? So you can see why It doesn't always work having these decimal places. Now, if we try three significant figures, we go 9, 4, 2, chop it off there. 2 looks at the 4. And so in this case, this looks a bit weird. So we're basically rounding to the nearest 1,000. So the nearest 1,000 is 942,000. And so the 400 gets rounded down. So because it's in the hundreds column. So now you write the number 9.42. There's our three significant figures times 10. Now, how many moves are we doing here? So if our decimal place was here, we have to go 1, 2, 3, 4, 5. Am I getting that right? So it's times 10 to the 5 times 10 to the 5. And that's how you work these all out. Now, these are questions from last year's exam. And if you look at these, we've got numbers here and here. So if we actually just, because we're talking about significant figures in this video, if you look at this one, we've got 1, 2, 3, 4, that's got 6 sig figs. And this next one, the 0 doesn't count. So it's 1, 2, 3, 4, 5, 6. So both got 6 significant figures. And they're saying they only want 3. So what do? We've got 4, 2, 9. We've got to cut that off. The 9 looks at the 8. The rest doesn't matter. So that would be 42 point. Oh, wait, the 9 has to go up. So it's not 42.9, it's 43.0. And immediately, that means I can rule out A and B and D. Isn't that nice? And then we look at the next one. So the 0 doesn't count, and we've got 8, 7, 7. That's 3 significant figures. We chop it off. 7 looks at the 4. These are the 4 and 7 don't matter. So 7 looks at the 4, stays on the floor. So it looks like this one's going to be 0.877. So the answer must be E. Okay, the next question has a few tricks in it. Now this time they're saying they want the correlation coefficient rounded to 3 decimal places. All right. Now they've given us the coefficient of determination, which is this. So you should perhaps know that this is r squared, and the correlation coefficient is r. So if you want to go from r squared to r, then you have to square root. So if you put this number into your calculator, you'll get something like this. Let's just delete all that. Now what I've done here is done hat 0.5. That's exactly the same as square rooting. Just a little quick trick there, because and so 9 square rooted equals 3, but also 9 to the power half equals 3. It's just another thing you should probably know. And you get this number, and then you go to 3 decimal places and you chop off here, and the 5 looks at the 3. None of that matters. So you get 0.945, and you choose E, and you're wrong. What happened? Well, the thing is, when you square root 9, you actually get plus or minus 3, because negative 3 times negative 3 also equals 9. But if you look up here, and there's a little piece of information you might be missing, is this minus here. So if what we're saying in here is we've actually got a situation where we've got a negative slope. So if the slope is negative, r is negative. So we don't want the positive root. The calculator only gives you the positive root. It doesn't give you the negative root. The actual answer is A. A lot of little tricks in just one little question there. But again, some nice rounding there. And you can see where people rounded things weirdly or squared the number instead of square rooting it. Okay, again, this one's taken from last year's exam. And the first part is name the explanatory variable. You can cheat a little bit because the next part, part B, says y equals a plus bx. X is explanatory, so it must be 9 a.m. That must be a very easy 1 mark right there. They sort of gave you the answer away, didn't they? So next part is we need to determine the values of the intercept and the slope. This one's the intercept, this one's the slope. Make sure you get that the right way around. Slope is next to the x, right? So do that, and it says you've got to also, just to get the mark, round to 3 significant figures. All right, so you're going to have to hit the calculator. So first thing you do is put the datas in. So this one, this 2. regression, calc regression linear reg, you get this. X is in list 1. Always double check that has to be the case. And then you get these lovely values here. So I've always set my calculator to this format because, as you can see, that's the format they have here. There's the X's hidden under the calculator there. So I always leave my calculator in that format just because that's the way it's going to appear on the exam. Some of you may be used to y equals mx plus c or ax plus b, but there you go. Now, this means the A is this one and the B is this one. Let's start with the A. So 3 significant figures, we're going to go 1, 2, 3, we chop off here. 6 looks at the 1, the 7 and 8 don't matter. So you get minus 1.26. All right, and then the next one we look at is B. So 0, that first 0 doesn't count. So 7, 6, 4. 4 looks at the 9. The rest of those 9s don't matter. And you get 0.765. And that's the correct answer. Now, next part says, determine the value of the correlation coefficient. Is that R or R squared? It is R. So we want R, which luckily the calculator has given to us again. And this one, look like they've changed round to 3 decimal places. All right, let's do decimal places then. So R is 0.871. The 1 looks at the 2. The 5, 8, 7 don't matter. So it is 0.871. So it's a lovely, strong, positive R there.